So second day of graphing, we are going to graph in what is called slope-intercept form today. Ready, Lynn? Ready? All right, slope-intercept form. So this should be one that looks relatively familiar to you. This is probably what you're used to graphing in. It's maybe just been a second. So if you are graphing in slope-intercept form, probably one of the most important components of it is called the slope, okay? Slope is the ratio of the rise, to the run. Rise is the change in y, that's the change up and down. Run is the change in x, so that's the change left or right. And when it says a ratio, that means like a fraction. Ratios are fractions. Slope is typically represented with the letter m. I don't know why it's the letter m. Probably has to do with Latin or something. But slope is m. So these little bars here, these are fraction bars, okay? So m equals the rise over the run, written as a fraction. Or in other words, the change in y over the change in x. So how much y changes over how much x changes. The really important thing though is that y has to go on the top of your fraction. There is a formula for it. So if I give you points, there's a formula that you can plug it into. And that formula is y2 minus y1 over x2 minus x1. Sound familiar? Good. These come from coordinate points. So if I give you coordinate points, we'll label which ones are x1, y1, which ones are x2, y2, and then plug it in. If I give you a formula or an equation in standard form, that's what we did last week, then you find the slope by taking the opposite of the a term over the b term, and we'll practice that today. To find the slope of any line, pick 2 points and simply plug it into your formula. Slopes can come in a few different forms. We can have positive slopes. Positive slopes go up and to the right. Think like you're literally going uphill, right? It's positive. Negative slopes go down and to the right. Again, think like you're going downhill. What do we do if we have a horizontal or a vertical line, though? Slope in this situation is a little bit different. So let's say I have a horizontal line like y equals 4. Okay? Now, we're going to practice finding the slope of this. We're going to practice using our formula. So let me rewrite our formula up here for us. Our formula is y2 minus y1 over x2 minus x1. We're going to practice this formula by figuring out what the slope of a horizontal line is and what the slope of a vertical line is, because it works a little differently. So to find the slope of a line, all you have to do is pick any 2 points on it and plug it into your formula. So what we're going to do is pick 2 points on this. How about this point here? This is the point 0, 4. And then we'll pick another one, doesn't matter which one. How about right here? That's 9, 4. Okay. So those are the 2 points we're going to deal with. Okay. So next thing I would do is figure out which one's going to be my x1, y1, which one's going to be my x2, y2. It doesn't matter which one you do for which, okay? It's going to be the same whether you go from right to left or left to right. So I'm going to say this is my x1, y1, and this one's going to be my x2, y2. And now I'm just going to plug this into my formula. So remember, my formula is m equals y2 minus y1 over x2 minus x1. So all you really have to think about is subtract your y's on top, subtract your x's on the bottom. But whatever order you go in on the top, you have to go in that same order on the bottom. So like if you pick the point on the left first, you have to pick the point on the left first again. So if we do this, take your y's are 4 and 4, right? So on the top, we're going to do 4 minus 4. Then put your fraction bar. Then on the bottom, we have 9 and 0. So then do 9 minus 0. What's 4 minus 4? 0. What's 9 minus 0? 9. What's 0 divided by any number? 0. This happens with every single horizontal line. All horizontal lines have a slope of 0. A way to kind of think of slope, think like if you were climbing up a hill, right? The steeper that hill is, it's going to be harder to climb up, right? So if you have a really steep slope, a really steep upward slope, which I guess for you guys would actually look like this because it's backwards. If you have a really steep upward slope, it's going to be a bigger number, slopes like 5 to whole numbers, okay? If you have a downward slope, though, it's going to be smaller numbers. Isn't it easier to walk down, right? Okay, what if you're on a flat surface? Does that take any effort at all to walk across? No, that's why that slope is 0, right? It's flat, it's 0. So the slope of all horizontal lines is 0. Okay, well then a vertical line. Can you even walk up a vertical line? Not unless you're like Spider-Man or like one of those cliff climbing people. Okay, so think about that while we find this slope. Let's see what happens here. So pick 2 points again. Let's pick this one here. This is 6, 0. And then, it doesn't matter which other one. Let's go up here. This one is 6, 7. I'm going to say this bottom one is my x1 and my y1, and this top one is my x2 and my y2. And then I'm going to plug this in to my y2 minus y1 over x2 minus x1 formula. So on the top, subtract your y's. We're going to do 7 minus 0. And then on the bottom, aren't they both 6's? So we're just going to do 6 minus 6. What's 7 minus 0? 7. What's 6 minus 6? 0. Anyone notice something funny about that? This is this is a weird math rule that sometimes people forget about. I have a problem with what this looks like. Asia? Not necessarily that it's improper. Improper fractions will happen. That's okay. Are there any numbers that you're not allowed to divide by? 0. And are we currently dividing by 0? Is that a problem? Yes. What we say for something like this is we say this is undefined. You are not allowed to divide by 0. All vertical lines are going to have an undefined, thank you, Alex, an undefined slope. So now think about it when we talked about like the hill. Again, can you like walk up a completely vertical hill? No, it's not possible, so you would say undefined, right? If it's flat, that's easy, that's 0. 0 effort, right? Vertical, can't do it, undefined. It's kind of like a little way to remember it, okay? All right, so now what we're going to do is we are going to practice just finding slopes in general, just with coordinate points. This is good practice for using our formula. So it says describe and find the slope. We're just going to worry about like finding it. Describe it means is it like positive or negative? Okay, so we're just going to practice finding our slopes here. I give you 2 points. If I give you 2 points, all I want you to do is plug it into your formula. First thing I would do is label which one you want to be your x1, y1, and which one you want to be your x2, y2. So I tend to just go in order. I'm going to say this is my x1, y1. This is my x2, y2. Okay. And then we're even going to do a little color coding. We're going to make this even, if you guys have highlighters or anything, it could be a nice way to do it. Okay. Y's need to go with Y's, right? And X's need to go with X's. Okay, just to make sure you're keeping the correct numbers together, please stop. Okay. So we are going to plug this into our formula. So I'm just going to keep writing it so that it hopefully sticks in our brains. Our formula is m equals y2 minus y1 over x2 minus x1. So we need to put our y's on the top, right? Y2 first, minus sign, and then y1. What's your y2 number? -2. Then automatically put a subtraction sign. And then what's your y1 number? -4, good. And then put your fraction bar. Then on the bottom, what's your x2 number? 6. Automatically put a subtraction sign. What's your x1 number? -2. All right. Now, here's why I always want you to write all this out. You guys notice how there's double negatives? Yeah, will we be able to fix those eventually? Absolutely. Do I want you to change them right away? No, I want you to write it out like this first, because if you don't, you're so much more likely to make a sign mistake, okay? So please write it out like this first, then we can go through and change. 2 negatives is going to change to a what? A positive. So now we can go back and change those, but I would write them as 2 negatives first so you don't mess up a sign. Does that kind of make sense? If you guys start going and switching things around, you're bound to make a silly mistake. So now let's simplify this. What is -2 plus 4? You're thinking times. We're adding -2 plus 4. Just +2, yeah. Are we allowed to use calculators, guys? Yes. And then on the bottom, what's 6 plus 2? 8. Do you think this is good the way it is, or should I simplify? We should definitely simplify. Anyone know what can go into both 2 and 8? I heard a couple people whisper it. 2. All right, so on top, what's 2 divided by 2? 1. What's 8 divided by 2? 4. And that would be our slope. Okay? All right, we're going to try that with another one, with number 2. Do we all have this copied down before I move over? Okay. All right, number 2 is going to be very similar. Okay, I would start by picking out your x1s, your y1s, etc. So this is my x1, my y1, my x2, and my y2. And then it's always nice to color code so you keep your y's with your y's and your x's with your x's. So -7 is a y and 3 is a y. And then 1 is an x and 5 is an x. All right. So now let's plug this into our formula. On the top, we need to subtract our y's, right? So y2 minus y1. Brooklyn, what's my y2 value? 3. Then put your subtraction sign. Forgot about my color coding. So 3, then put a subtraction sign, and then Asia, what's your y1 number? -7. So on top, you should have 3 minus a -7. Then put your fraction bar, and then on the bottom, Hayden, what's your x2 value? 5. And then Corey, what's your x1 value? 1. So we'll have 5 minus 1. And then we're going to simplify. Olivia, what should I do before I start simplifying though? Do you notice? Yeah, we need to change. We have double negatives here. Make those positives first. 3 plus 7 is going to give us 10. 5 minus 1 is going to give us 4. Should we reduce that? Definitely. What can I reduce that by? 2. They're both even numbers. If you guys ever see even numbers, always try 2 first, and then if you need to reduce again, you can. Question or stretching? Okay. So what's 10 divided by 2? 5. What's 4 divided by 2? 2. So our slope here would be 5/2. Questions on that yet? No? Okay. So numbers 3 and 4. I'm going to show you 2 strategies for this. Well, actually, we're going to do one, but I'm going to explain 2. First of all, this one's a little different because it's a picture, right? Does that picture have numbers on it? Yes. So could I take my numbers and plug them into my formula? Absolutely. But I want to show you another strategy because it's going to help you a lot with graphing, okay? So when you're graphing, the easiest way to find slope is actually by counting. We're going to practice this a lot, but it's an important skill to have. Technically, your slope is just your rise over your run, right? Okay. Rise is whatever the change is up and down. Run is whatever you go left or right. So if you have a graph, can't you also just like count your boxes? That's what we're going to do here. I always count from left to right. And I think that that's a good strategy for you guys too. It actually doesn't make a difference, but it's a good approach to it. It's a good strategy. Because if you're always going from left to right, you're keeping it consistent every single problem. Now, a couple of things about counting on a graph. If I'm counting up, Aaron, are you on your phone? Put your phone away. If you're counting up, is this going to be a positive or a negative value? If I'm counting up. Positive. What if I'm counting down? Negative. What if I'm counting to the right? Positive. What if I'm counting to the left? Negative. Okay. So here, if I want to count from the left to the right, I'm going to count up or down first and then left or right. So if I'm trying to get from this point to this point, would it make more sense to count up or to count down? Down, right? Because isn't this line kind of going downwards? So I'm going to start at this point and I'm going to count down. So I'm going to count down 1, 2, 3, 4 units. Now, why did I stop there? Yeah, because isn't that also where your other point ends up being, right? Doesn't it end up being on that same little line there? So I counted down 4. So that means my rise is -4 because it went down 4. Then from here, would it make sense to count to the left or to the right? To the right. So I'm going to then count to the right. 1, 2, 3. If I'm counting to the right, is that positive or negative? If I'm counting to the right, it's positive. So that would be a +3. So my slope is -4/3. That means I went down 4 and over 3. A little bit quicker than using your formula, right? Could you use your formula? Sure. Do you need to if you have a picture like this?
Yeah.
No, you don't. So, number 4, let's try this again. This one again, I have points that I could use if I wanted to, but instead we're going to count this out. So, remember your slope is your rise over your run. So we're going to count up or down and then left or right. So for this one, if I'm going from left to right, isn't my line going upwards? So from my first point, my one all the way on the left, would it make more sense to count up or to count down? Up. So from here, I'm going to count up 1, 2, 3, 4, 5 units. And then I stop there because doesn't that line up with my other point? So I counted up 5, so my rise is 5. Then I need to count left or right? Right. So I'm going to count right. 1, 2, 3, 4, 5. Would that be positive or negative 5? Positive, because I went to the right. And then can I reduce the number 5 over 5?
Yeah.
What's 5 over 5 going to be?
1.
Just 1. So my slope here is 1. That means for every time I go up 1, I go, nope, right 1.
Right 1.
I go up 1, I go right 1. I go up 1, I go right 1. That's how that works. All right, we're going to try this 2 more times. Then we'll take a little break and then we'll do some graphing. So number 5. So now this one, there's no numbers, right? But I do have some dots I could use. So we're going to go based off where these little dots are. First of all, do you think that this graph has a positive or a negative slope? Negative, it's like going downhill, right? So go from your leftmost point to your rightmost point. So from there, if I'm starting here, would it make sense to count up or to count down? Down. So count each unit. 1, 2, 3, 4, 5, 6. If I went down, what kind of a 6 should it be? Negative. Then do I need to count to the left or to the right? To the right. To the right, 1 and then 2, and then don't I hit my other point? Yep, so that's a 2. Positive because we went to the right. Can you reduce negative 6 over 2? Definitely. Anyone know what it would reduce to? Yes. Do you have to put the 1? Can you? Sure. Yeah, it doesn't really matter. But with this one, negative 6 is divisible by 2. So you could make it just negative 3. But I would also take negative 3 over 1 if that helps you. Okay. What this means in terms of a graph is you would go down 3 units and then right 1 unit. Down 3 units, right 1 unit. All right. And then last one for this part, number 6. We have our 2 points. Does this graph have a positive or a negative slope? Positive. It's going up, right? So it has a positive slope. Start all the way on the left here. Should I count up or down? Up. Up 1, 2, 3, 4, 5, 6, 7, 8. Positive or negative 8 though? Positive because I went up. Then should I count to the left or to the right? To the right. 1 and then 2 because I hit my other point. So that'd be a positive 2. Is 8 divisible by 2? Yeah, what's 8 divided by 2? 4. So you could either write this as 4 over 1 if you want, or just 4. What that means is every 4 units up you go over 1. So you'd go up 4, over 1. Okay. We are going to back on the notes. People at home, can you see my notes again? They're all ignoring me. Thank you. All right, so now we are going to talk about how to actually graph in slope-intercept form. We have found slopes. We are now going to graph. So, graphing in slope-intercept form. A linear equation written in the form y equals mx plus b. Sound familiar? No. So y equals mx plus b. That is where m is the slope. Okay. And then this b that's on the back here is the y-intercept. And we talked about intercepts last week. So then you can also have graphs that are constant functions. That is either written in the form y equals 0 m plus b. That means there's no slope. Okay. Or just y equals b. Okay, that is a horizontal line. We practiced graphing those last week. So we actually, I don't think we're going to graph any more of those today because we already did a bunch of them. And I feel like we did pretty good with those, right? Graphing our horizontal and vertical lines. Okay, so we are going to graph each equation in slope and intercept form. We're going to plot at least 3 points. 2 points is okay when you're doing standard form because you just find your x-intercept, your y-intercept. That's really all you have. 3 points is a lot more accurate though. So we're going to plot at least 3 points and we're going to identify the slope and the y-intercept. So this equation for number 1 is in the form y equals mx plus b, where m is the slope and b is the y-intercept. Now what's kind of nice about these is you're given all the information you need. Slope, your slope is whatever number is in front of your x. So here, do you guys see the number 3 in front of your x? That is your slope. So in our little line for slope, we're going to write down 3. Your y-intercept is whatever number is being added or subtracted on the back, which in this case is -4. Now, we don't want to just put a -4 on our line though, because isn't an intercept a point? Remember when we did that last week? Remember, an intercept needs to be written as a point, which is like x, comma, y. Now, if it's a y-intercept, what's your number for x? Who remembers? That's your number for y. What would your number for x be? 0. A y-intercept is always 0, comma, and then your number. Does that sound familiar, guys? Yeah. 0, -4. Okay. Now, how does this help me? What am I going to do with this? Well, don't I need to plot 3 points? Don't I have a point now? Isn't this a point? Can I plot it? Yes, you should. So 0, -4. That means go to your y-axis and put a dot at -4. So there's 1 down. Now, where am I going to get my other 2 points from? Well, I have a slope, don't I? That slope tells you how much your graph either goes up or goes down. Now, it's a positive slope, right? So if it's a positive slope, my graph's going to go upwards. So what you do to count out a slope of 3, slope is rise over run, right? So if you have a whole number like this, how it works is your graph would go up 3 units and then to the right 1 unit. Because isn't 3 over 1 just 3? Yeah. So what you're going to do is from this point that you're given, from your y-intercept, you're going to count up 1, 2, 3, and then go over to the right 1 unit. Now the reason you go up and then to the right is because isn't your 3 positive? So you want to go in the positive direction, so that's up and to the right. Then you're going to do that one more time. We're going to go up, 1, 2, 3, right, 1. So then put a dot at 2, 2. I would count it. Don't try to stare at mine because you're going to plot it in the right place. Practice counting it. Go up, 1, 2, 3, right, 1. Go up, 1, 2, 3, right, 1. You should end up with a point at 1, -1, and at 2, 2. Then we need to connect them with a nice line that has our arrows on either side. Use your straight edge. I would if I could. Okay, so this is the general process for this. You find your slope, find your y-intercept, plot them, connect them with a line. Do we all have this one done? Okay, so go over to number 2. Okay, so your slope is whatever's in front of x, your y-intercept is whatever's added or subtracted on the back. So what number here would be your slope? -6. So should this graph go up or down? Down, because it's negative. Okay, so my slope is -6. That's just a number. What's my y-intercept? 1. Good. How do I properly write that as a point, though? Good. 0, 1. Okay. So now I have a place to start. On your y-axis, go to 1. Now we need a slope of -6. If it's negative, do you think it would make sense to count up or to count down? Probably to count down, right? So we're going to count down 1, 2, 3, 4, 5, 6. Now the question is then, do you go left or right? Well, you want it to be negative, right? And if we went in the negative direction and then in the negative direction again, what's 2 negatives make? A positive. We don't want it to be positive, right? So that means we're going to go down 6, but then right 1. And now I have an issue. I need 3 points. Can I count down 6 and right 1 again? No, it's not going to fit. Right. Very good. Now, yeah, because if I go up and to the left, isn't that going in the positive direction and then the negative direction? That works out the same. It like balances itself out. If I count down, I have to go to the right. If I count up, I have to go to the left. So I'm going to count up, 1, 2, and you go from your original point, like your intercept. So count up, and it might not fit perfectly, but that's okay. 1, 2, 3, 4, 5, 6. It just goes off just a little bit, and then over 1. And then connect those. Oops, but do a better job than me, because you have rulers and I do not. All right. Jaden, you got this copied? Corey, do you have this copied? All right, we good with this one? Can I move over? All right. All right, so now what's a little different about this one is don't we have a fraction in it? That's okay. Sometimes actually fraction slopes are like easier to count out because you can see exactly what you need to do. So this is still your slope. So remember, slope is whatever's right in front of x. So that in this situation, oh, wrong color, is going to be the -2 over 3. Okay, so that's your slope. And then what's your y-intercept? Yep, it's this -7. So your slope is -2 over 3, and your y-intercept would be 0, -7. Good. So now let's plot this. So you're going to put a dot where to start? At -7. Now I know, I apologize that doesn't quite fit, but I would just go to the bottom of your arrow, like right there. Right, that's probably like one more unit. I changed my graphs and forgot that a few things wouldn't fit. Okay, now you have a slope of -2/3. So the question is, well, how do I count that, right? There's two numbers. You have a 2 and a 3. The negative, it doesn't matter if you put the negative with the 2 or the 3. If you have a negative slope, you either count down and to the right or up and to the left. Now from here, is it going to work to count down and to the right? No. So instead you have to do the opposite. We're going to count up and to the left. Now if it's 2, 3, we're going to count up 1, 2, and then left 1, 2, 3. Because that'll be up 2 and then over 3. Up 2, left 3. And then you can do that again. Go up 1, 2, left 1, 2, 3. Practice counting that out. And then I just connect those with my line. People at home, how are we doing so far? They don't want to talk to me. Okay, thank you, Mason. One person answered me. Okay, good, thank you. Heard from another person too, just making sure we're awake over there. All right, do we kind of understand the fraction part? So the number on the top, that's where you count up or down. Number on the bottom is how you count left or right. So now let's look at number 3. Does this graph have a positive or a negative slope? Positive. What is that positive slope? 4 over 3. So that is your slope is 4 over 3. What's our y-intercept? Yep, it's this positive 3, so we write that as 0, 3. So again, our slope is 4 over 3. Our y-intercept is 0, 3. Aaron, where do I start when I'm going to now graph this? Where's the first place I should put a point? Yep, 3 on the y-axis, right? Okay, now I'm going to count out my slope. I have a slope of 4 over 3. How do you think I would count out a slope of 4 over 3? Up, down, left, right? What do you think I should do, Jake? Yeah, you would go up 4 and then right 3. Now that'll sort of fit, right? I can go to the top of my arrow there. So let's do that. So we're going to count up 1, 2, 3, 4. Right 1, 2, 3. So that's going to get us to right here. Goes off a little bit. That's okay. Can I do that again though? No, yeah, not really. We'd have to do some weird estimating. So Annalise, what do you think I should do instead? Yeah, from that first point, just do the opposite. If we went up and to the right, we're going to go down and to the left. So down 1, 2, 3, 4, left 1, 2, 3. And then connect it. Why are you just saying numbers? We don't want to continue the counting. We want to stop it where our dot is. I know I'm struggling with this line. Best I could do right now. Struggling with that one. All right. Got a couple more, I think. Yes, okay. So I want, we're gonna do number 3 together, and then I'm gonna have you guys try out number 4 on your own. Okay? So number 3, the reason I wanna look at this one is because your slope looks a little funny. What looks a little funny about my slope? there's really no number there, right? Now, if you have a variable and you cannot physically see a number there, who remembers what number is actually there, Aiden? 1. In this case, we have a negative, so it would also be a -1. So for this one, my slope is -1 because of this negative sign in front of there. Very good. If there was no negative sign, it would just be a +1, okay? So my slope is -1. What's my y-intercept? Very good, 0, 5. I love that we're saying it as a coordinate point. I have trained you well. Well, not you, because you're not doing much over there. So 0, 5. You're right, I just have no idea what I'm talking about. So put a dot at 0, 5. And then we have a slope of -1. Now, how would you count out a slope of -1? Well, 1 where? Down, left, right? Okay, so we're gonna go down 1, and then from there, where do you think? Left or right? So if I went down and left, isn't that a double negative? What's a double negative make? A positive. So do I wanna go down and left? No, you should go down and right. And then can I do that again? Why not? It'll fit. Down and right again. Not really. You could do that as many times as you wanted to. So then we're going to connect that with our line. And there it is. Sometimes those throw people off, but if you one, just go down and to the right or up and to the left, or if it's positive, up and to the right. Okay. All right, I want you guys to try out number 4. And I'm going to call on random people. Try out number 4. Depends on who I make eye contact with, I guess. So don't look at me. Thank you, Asia. That's a typo. This should be a y equals. My bad. Thank you for pointing that out to me. It's a y equals. I know, it's a typo. First one should be a y. I didn't even notice it either until Asia just pointed it out to me. Yeah, I still need to make my index cards. I just don't have
Or do you? Just not used to them.
No, I really don't.
Busy bee? What are you so busy with? Work. Work.
Yeah, getting all the stuff online. I teach new classes here.
What class?
Geometry GT.
What's that?
It's like honors geometry.
That's geometry.
Yeah, I have Charlie in 7th block in regular geometry.
That's geometry. Is that required?
Geometry GT?
Yeah.
Not GT, but regular geometry is required. It's like honors.
What's the difference?
We do a lot harder stuff.
Do you have to take geometry to take geometry too?
I'm not a genie.
I don't know. You could be. I could probably fit you in a bottle and then go rub you and then you'll fly out like in Aladdin.
So many things about that were so strange. I want you to know that. And I'm just gonna keep going. I'm just gonna keep going with my day. First of all, don't put people in bottles. Number 1, don't put anyone in a bottle. Because that sounds like abuse. I don't want to be a genie. I said I'm not a genie. Okay. Anyway, number 4. All right, this one, I apologize. I gave you guys, you needed a bigger graph for this one, but that's okay. We'll get through it. Dallas, what's my slope for number 4? Yeah, 1 over 4. Lynn, what's my y-intercept? Yeah, 0, -7. Bailey, where's the first place I should put a dot for this one? Yeah, it's gonna go a little off the graph.
All right, guys.
All right, then I need to count out my slope. Let's see, who should I bug? Aiden, how do I count out a slope of 1/4? Yeah, you go up 1 over 4. It goes a little weird here, but we're gonna go up 1 and then over 1, 2, 3, 4. This one works out okay. But then you gotta go do it again. It's gonna go off the graph a little bit. Go up 1, over 1, 2, and then just estimate. I'm gonna say 3, 4. Just do the best you can. Except I just drew the worst line of all time. It's very hard to draw a straight line with this tablet. I cannot use a ruler on a tablet. If I could, I would. It won't work like that. Because if you touch this device with something else other than this, it can't tell the difference between the two. I can do it with my finger too.
Yeah, put your finger.
I can use whatever I want, really. I mean, I guess not this, but it doesn't quite work. Plus, too, the plastic rulers and the wooden rulers are going to scratch up my screen. All right. Anyway, last thing now. See what we have time for with this. So, number 5. What's weird about number 5? Yeah, it's not in the right form. Now that's okay though, because we learned about these last week. These are the ones we did the cover-up method for. Yes. Now, let's take a look though. We're going to review, don't worry. So, now here's what we're going to do for this. Now it says though to graph it in slope-intercept form. So I still want to find a slope. I still want to find my y-intercept. Now, if this is written like this, what you do to find your slope is you take the opposite of the A value over your B value. Now the question is, what are those? Okay. Your A value is whatever number is in front of X. What number is in front of X? What kind of a 3? A -3. Okay. Your B value is whatever's in front of Y. What number is in front of Y? 2. Okay. So to find the slope here, you just take the opposite of whatever A is over B. Now, if A is -3, what's the opposite of -3? Positive 3 over 2. And that's your slope. Now, we still need a y-intercept, but can I do my cover-up method and find my y-intercept? What letter do I cover up to find my y-intercept? Yeah, cover up X. So don't actually scribble this out, but I'm going to because I can erase it. So pretend X isn't there. We have 2y equals 8. What would you do from there? Divide by 2 and you would get 4. How do you write that as a coordinate point? 0, 4. Now, so we now have 0, 4, and 3, 2. So put a dot at 0, 4. And then how do you count out a slope of 3, 2? Yeah. Is 3 going to fit great? No, but could I do it? Sure, you could. So we're going to count up 1, 2, 3 over 1, 2. Do I want to do that again though? Yeah, no, I would go from your original point and go down 1, 2, 3, and then over the other direction 1, 2, and then put a dot there. And then put your line through that. Okay. It's a little bit trickier, but it's doable. Okay, you don't have to do this for all of them, just these ones that are in this weird form. Now, could you also just do your cover-up method for it? Yes, there's really no reason not to, except there's one little thing that I want to point out to you. Take a look. If I covered up y, wouldn't you have negative 3x equals 8? Is 8 divisible by negative 3? No. So is that going to work out and give you a nice coordinate point? No. So that's why I wouldn't do it like that, and I'd do it like this instead. So last one, you have 3x minus 5y equals 10. We need our slope and our y-intercept. Now this is not in slope-intercept form, so we're going to find our slope by doing the opposite of A over B. Who remembers where I can find my A value? Aiden? Super close. This one's a little trickier because the order switched. So where does my A value live though? Like in my problem, is it in front of X or in front of Y? In front of X. And here your X is is 3, right? And then your B value lives in front of what? The Y. So that's negative 5. So now you do the opposite of A and then just over B. What would be the opposite of the opposite of positive 3? Negative 3 over negative 5. And if I have a double negative, I should change that into a positive. Okay, good. Then we have our y-intercept. What letter do I cover up to find my y-intercept here? X. So cover that up, and you'll have negative 5y equals 10. Dallas? Because if you take a look at the other one, wasn't your y first and then your x second? And this one, your x is first and your y is second. The order switched. Okay, you don't see too many of these, so I wouldn't panic about it too much. We do a few of them on our stained glass window, but we'll do like at least one together before, okay? And I think I only make you graph like 2 of them, I think. So then what would you do from here? Yeah, divide, and you should get negative 2. How do I write that as a point? 0, negative 2. So put a dot at negative 2, and then how would I count out a slope of 3/5? Would I go up or down? If it's positive, I would start by going up and to the right. If that doesn't fit, Annalise, then you would go down and to the left. Because what's a negative divided by a negative? A positive. Does that make sense? Were you looking at and you could use the negative over a negative. You would just have to go down and left. Does that make sense, Annalise? Okay. Does that make sense, Dallas? Sort of. Okay. So up 3, that's 1, 2, 3 over 5. 1, 2, 3, 4, 5. So you would land at 5, 1. But now can I do that again? No. So then you go to your other coordinate and go down 1, 2, 3, and then left 1, 2, 3, 4, 5. And then you're done. Okay?